talked about the different parts of the chemical formula, coefficients, subscripts, bracket subscripts. We did counting atoms again. I have a video posted online about counting atoms along with the counting atoms in a formula worksheet. So if that's a skill you're still having trouble with, that's going to be an essential skill for balancing equations. But I don't think, you guys are going to find this counting a little easier because I'm going to show you we're going to change one of the things that we do. But so I'm going to be going through day 2/3 here. The first one is just an example, but I want to go through that with you. So we have an equation here, calcium hydroxide.
That's exactly what I was about to do.
All right, and while I'm writing this up here, I want you to be thinking about what type of chemical reaction this is. These are your choices here: synthesis, decomposition, single replacement, double replacement, or combustion. This is one of the things we're testing on right now. So this is good review. At the same time, we're doing a new skill. All right, we've got calcium chloride on this side plus iron hydroxide. Okay, so first thing, you're just going to take a minute. Now I want you to turn to somebody near to you. So 1, 2, there. And let's see. Helen, you can talk that group there. Sydney, you mind coming up here and you're going to work with Thomas and Jalen, okay?
So is it me and Tony?
The three of you. You're just having a triangle. And you're going to talk about what kind of chemical reaction this is. And if one of you doesn't know, you're going to explain to them why you think it is what it is, okay? So, and all three of you should agree when you're done. All right, so.
It's combustion because of oxygen. Huh? What's the replacement?
Look at that reaction and tell you it's a double replacement.
Wait.
Calcium goes with the chlorine and the Fe goes with the oxygen.
Either combustion or double replacement. Final answers. I don't know. I suck at these.
Yes, you're absolutely right.
I
And
finally did the
that
front end
oxygen
studies.
hydrogen thing is a polyatomic ion called hydroxide.
That a couple days ago.
So it
There's
kind of
like,
moves around
they're like 2
together.
days. I was like, you need to
And
apologize.
so one key thing, we
I'm
know
sorry I
all
said
the
You see what I posted yesterday?
because they
What's
have
up?
Bunker.
right? And if you have two ionic compounds on both sides of the equation, it's going to be a double replacement equation.
Bunker.
Okay? Yeah.
Broccoli.
Yeah, you were right.
Sweet
So,
potato.
and it's just, yeah, the two metals in this case are switching places.
I like your earring.
Oh, thank you.
You like mine?
You know, my daughter got those for me, they're little,
That was
orchids
weird.
because I like to go hiking and find wildflowers.
I have
My
a
favorite thing.
usually,
Hold my hoops.
How's your,
Let's get our ears pierced and get
All
hoops.
right, so what did you
Yes.
guys come up with?
Double replacement.
Double replacement, okay.
yes.
All right, and how about over here, what do you think?
Combustion, please.
no, we didn't.
I think it's combustion.
No, we didn't.
Yeah, I see what you're saying, and that would be one way to look at it, but they do call that a double replacement, and the reason, there are two
How did-
compounds on both sides, and when you have two compounds that are collecting metals, basically, so calcium and iron are really metals. And so they just switch places, right? And whenever that happens, they just call that a double replacement. Okay, yeah, in the single replacement, what you'll have is you'll have one compound plus like say, you have iron here. And so if you had one compound plus like a pure element that switched places with the calcium, then that would be a single replacement. But if it's two compounds, on both sides, it's gonna be double replacement. Okay? All right, so good job, guys. It looks like everybody concluded that that was double replacement. So key thing is if it's two compounds, ionic compounds on both sides of the equation, it's going to be a double replacement reaction. Okay? All right, so now figure out how can we balance this equation, or we're taking the first step of that, which is just finding out if it's balanced. I'm not even asking you guys to balance them yet. And so we have to look at the atoms of each kind of element on both sides of the equation. So we've got reactants on one side, right? This is everything that we started with, and products are everything that we ended up with on the other side. We know law of conservation of mass says we can't create or destroy matter. So we have to have the same number of atoms of each type on both sides of the equation. So we're going to figure that out by counting the atoms on both sides of the equation. Just like we counted atoms in a formula, but now we're just going to kind of combine everything on this side of the equation into a list. I'm going to go here and I'm going to list all the elements that are present. Okay, so I've got calcium. Now, when we get to our polyatomic ions, then I will underline those for you. They're easy to spot when they're in brackets. And let's see, did I do that correctly? Yeah, I should have had a 2 on the outside of the bracket. That was a mistake. There we go. All right, so that says I have 2 of this polyatomic ion, which is called hydroxide here. Okay, so when it's in brackets, it's easy to recognize, but like sometimes they're not. Say in the compound NaOH, it would just be like that, and I will underline it so you'll know that that's a polyatomic ion, and when I count it for balancing purposes, I'm going to keep it together, okay? So I've got OH, it's going to be my next thing. I'm going to write iron and chlorine. That's just all going to be in one list. I like to keep them in the same order on both sides because then I don't get confused when I'm comparing. So I'll have calcium, chlorine, wait, I did it in the wrong order now. Calcium, hydroxide, iron, and chlorine, okay? So then I just go through and count like you guys have learned to with formulas. So calcium has a subscript of 1, right? No subscript is 1. Multiply it times the 3. I have 3 calciums. I'm going to write 2 times 3 for my hydroxide, right? I have 2 copies of hydroxide. And I have a coefficient of 3. So that's going to be a total of 6 for that. 1 iron and 3 chlorines. On this side, calcium, 3 times 1. I've got my imaginary 1 there. That's going to be a 3. Okay. And, oh, you switch it out?
Yes. Staring at me like I was doing something wrong.
Yeah, I don't. No, you're not doing anything right. Oh, I'm sorry.
No, it's just
You
because you have
a
long
very
hair.
intimidating stare.
All right, so chlorine's down here. That's going to be a 6.
Terrifying. Okay.
Okay, because I got a 2 here and a 3. 2 times 3, I've got 6 chlorines. And this one, on this side, I have 3 copies of that polyatomic ion, but I have a coefficient of 2, so hydroxide is going to be a 6 over here, and I have 2 irons.
The paper made a mistake or something. Because on the paper it says only 3 for the 6.
Yeah, I made a mistake. That is what I did.
Where?
Yep. And I put down that it was balanced, so I must have known it was balanced, and yet I put down the wrong numbers. Yeah, but we know that would be a 6. Okay, good catch. All right, so do I have the same numbers of everything on both sides?
No, your FE
No,
is different.
Oh, did I make a
Iron and
mistake on my
chlorine.
FE?
Iron and chlorine are different.
Yeah, you're right. Okay, so here, that's different. Oh yeah, that is different. Now I remember. So it's unbalanced, and I have that it's balanced. Wow, this thing's a mess. I'm gonna have to redo that. Okay, see, I do that on purpose so that you guys, I'll see if you can catch my mistakes.
That's what it
Yeah,
is,
good job. All right, so there we are. I messed that one up, but we're gonna get this one right. So at this point, if all I asked you is balanced or not, you would put unbalanced, okay?
Yes.
However, if we wanted to balance it, what could we do?
Want to take a picture?
Yeah, good idea. So what would be a good way? All right, so we can only balance equations by changing the numbers in front. Okay? Those are called the coefficients. why can't I change a subscript on one of those? Why can't I just go, like, say I wanted more iron here, I could change this to a 2 and change this to a 6. Why wouldn't that work?
Because
Because you
you can't
can't do that.
create.
It wouldn't create the same
I
outcome.
don't know.
Well, actually here, like, the reduced ratio would still be exactly the same, so for an ionic compound, the weight wouldn't matter. But you're changing the chemical formula. So like if I change like something here, like I made this 3 irons with 3 hydroxides, that wouldn't really work, but I'm changing what the molecule is, okay? That's what the subscripts tell us, is what the ratio of the elements is in the formula. The number in front tells us how many of that compound I have. So it's like if I said, I'm making a recipe and should I add I'm making 3 cups of flour and I'm gonna add in 1 cup of chocolate chips. But then I decide I'm gonna add in 2 cups of chocolate chips. Maybe that's the proper ratio, okay? So I'm not changing what I'm adding. Like if I added in 2 cups of butterscotch chips, that wouldn't be the same, right? The cookies wouldn't be the same anymore. But I could change the amount of chocolate chips that I was adding in to give the correct ratio. Let me explain that example again. Okay, so I've got a recipe of chocolate chip cookies. Normally the recipe is 2 cups of flour, 1 cup of chocolate chips, right? So I want to double the recipe, right?
Mm-hmm.
Okay, so then I would have 4 cups of flour, but I would also have to double the chocolate chips, right? I've got to keep the ratio of those different ingredients the same. I don't change what I'm adding, I just have to always, so when you're doing a chemical reaction, you have to have the correct ratio between the compounds, just like you do in the ingredients in a mixture. Right now, I do not have the correct ratio to get the products that I have over there. So I could fix that by putting a 2 in front of this, okay? If I do that, then I'm going to have, this is going to be times 2, this is going to be times 2, then my equation is going to be balanced, right?
Yeah.
Okay, so I just added more cups of chocolate chips.
Yeah, but you took
So-
away the 3 from behind the chlorine.
Yeah, I did. There. So, okay, so anyway, that's the basic idea. You want to, right now we're just trying to figure out if they're balanced or not, but once we start balancing, then you will be changing these numbers until you can get things to be balanced on either side. And we'll just work into that with baby steps. We have some different simulations and things that you can try, but it's just like solving a puzzle. Okay, so now you guys are gonna you're gonna turn your pages over and do the one at the top of page, or on the back there, and you're just gonna count the atoms and tell me whether it's balanced or not, and you can work further on that worksheet if you want.